Let's solve a problem where we want to find the longest word from a list. So I have a solution here also, but let's discuss it. So let's say I have some words. I will just use some simple words. So I have a word A, maybe B, C. So in this example, I will probably want to find this one here, but how to do it? How you would do it yourself? So again, let's say that you can read all the words, maybe they are in a separate page in a book, and you start from the left or from the beginning. So you probably go here and say, let's say currently the best or the best length and best word itself. So you probably try to memorize two things. Now you reach here, so you say that the best length is 1 and then the best word itself is A. You reach here, you see that this length is 2, so it's better than current best length, you say it's 2, and you memorize the text. Now you get here, it's 4, this is better, you memorize this one. You reach here, because this is 2, you don't change those. So this remains 4, this remains G. Now you get here, this should be 6, yes, 6, and now you write it here. And you get here, you still have the same best result. So you probably go through every page or every word, you compare the length with your current length, and if it's better, you memorize the word also. So you just try to memorize two things. Let's try to write it in code. I will have words here, which probably can be something like that. A, B, C, A, B, A, B, C, D, E, F, and A, B, C, there. And let's loop over for word in words. So now I have a word, I have to compare it to something. I can use the best length, but now for a computer, you can actually use the best value itself, because you can use the length of this length function. You know what is the length of this best word. So I can just memorize the best. And now the question is, what is current best? Let's say the current best is empty string. And if the length of the current word is, let's say, here, 1, 2, 4, 2, 6, 1. So you compare this one and this one always, and if it's bigger, then you overwrite it. But instead of having this best len, I will use the length of the best value. So because length of this value is always the value here. So if the current word's length is bigger than the length of the result, I can say that I can say that the current word is the best. So basically I ignore this one, but actually length of this best gives me the same values. So, and if I start from left, I always know what's the current best word. I also know what's the length of this best word because I can use function len. And now in the end I know that the best word, print longest word is best. And now the longest word is A, B, C, D, E, F. And again, if I want to know the position of the longest word, I probably have to use best index, like I is -1. And now if it's bigger, then I store I don't have the index here. I probably have to use enumerate here. Enumerate. So with enumerate, I get both the index and the value, or the word itself. And now I can store best index is I. Now if I start to think about it, I have indices here. I actually don't need the word itself, because instead of the word I can use words at position I. I mean, it's not so much of a deal. You can have two variables, but basically I can use only the position of the best. Now the only question is what to do in the first case. So what can I do if I don't have the best value? Otherwise I could use words at position not I, but the best I. So in this case I will probably just say that the best value in the beginning is 0, which means that the best value, or the longest value, is the first word. And now instead of best I can print out the words at position best I. This gives us the same result. And at position best I. Now in addition to the value itself, I also get the position. So I get the longest word and I get the position where this longest word is in this list.